All right, welcome everybody to this webinar together with Softlandia and Zoined, and today we're talking about why is Text-to-SQL so hard to get right. My name's Oliver. I'm going to be quick moderator here, asking questions from the public, maybe stepping in here and there, but overall it's going to be a laid-back discussion about this topic. So we have Sasa and Karipekka from Zoined, and then Olli-Pekka and Mikko from Softlandia joining us here. So please, Sasa, maybe introduce yourself.
Yeah, Sasa Moilanen from Zoined, one of the co-founders and working as the CEO in Zoined, but also in the product owner role, and been working with business intelligence topics for 24 years.
Karipekka Kaunisto, also a co-founder and CPO of Zoined. Mostly working with all the technical, especially backend stuff and integrations inside platform.
Hello all, my name is Olli-Pekka Heinisuo, and I'm one of the founders of Softlandia. My background is in software. I'm a software architect with an AI angle, so I focus on software and AI and the intersection of those two things.
And my name is Mikko Lehtimäki. Nice to be here. I'm also one of the founders of Softlandia. My background is in machine learning and signal processing. Did my PhD on simulating the brain, nice intersection of AI and biology there, and now working a lot with everything data related here at Softlandia.
Okay, so the idea today is really to dig deeper into why is Text-to-SQL so hard problem to solve. And I think to get everybody on the map first, I could maybe just share what this concept or topic means in the context of Zoined and our data analyst called Zed that is turning basically this kind of natural language queries into SQL and into nice visuals and so on. So let me share. Should come up hopefully now. So what we see here is now a practice. Generate SQL in order to query the data. So I would ask here something like, show me visitor conversion rate actuals for last week by store. And then what happens here in the background is that the query is run against our API, and then that one actually then generates the SQL in the background. So now we would see here for last week visitor hit rate by store, and we have all the stores and the hit rates here. So I think this is now maybe a good time to discuss a bit about what actually happens. So here we have Karipekka, who actually is like our database and data warehousing guru and database query optimization guru. So what exactly happens here? And maybe you can give a bit of more details.
Yeah, so basically, of course, the GPT will interpret the natural language and basically turn it to API call in our backend system. And the backend system is then responsible for this JSON-based request to generate the needed queries and combine the results so that in the end it will return a simple JSON dataset that can be rendered chart like this. So basically, there is a lot of metadata that helps the backend to formulate what kind of queries are needed and how to combine results from different queries to get the final output expected by the end user. So that is in a nutshell what happens behind the scenes.
Yeah. And I guess one of the reasons why this text-to-SQL problem is so difficult is that the actual SQL that needs to be generated is often pretty complex. So in this specific example, we are bit cutting the corners by just like giving the API something like a metric. Well, in this case, visitor hit rate. So that's actually a good thing about the LLMs, that they can convert these kind of things like me typing visitor conversion rate actually then to a metric that we internally call visitor hit rate. This is a synonym for that. But basically, to really get the SQL generated in the background, there's a lot of complex joins, and you have to fetch data from many different tables and possibilities for hallucinations and those kind of things. So, yeah, I mean, maybe we should let the Softlandia guys also chip into the discussion. So, how have you encountered this problem in your project, and where do you see the biggest bottlenecks and challenges?
Can't hear you, Mikko.
Can you hear me?
There we go.
Okay, thanks. Yeah, I think this is a very nice application of language models, because there's a lot of data, open and closed data, that is not utilized to its full potential. It's previously taken a lot of human hours to make raw data into actual information, and now that language models, large language models especially, are very helpful in actually accessing that data and making it available to even those that are not necessarily data professionals. So it's a very lovely use case.
Mm-hmm.
Yeah, and one thing what we see very often is that in this example, the language model is very capable of turning that user natural language query to the actual SQL query in the backend. But when the user asks something like, in his own terms, let's say he replaces that store word with some, for example, city, let's say London. So the language model at that point, it doesn't anymore know what the user actually means. So London might mean a store or a city or something else in this system. So that's one of the hard problems, understanding the user's intent, what we are seeing quite often in this kind of systems.
Mm.
Yeah, and it's actually quite fascinating. Like when we started building these things, I think it became like a potential use case with GPT 3.5. And back then the problem was that, can this thing actually generate valid SQL queries? Well, now that's pretty much taken for granted. It's nowhere near perfect, but pretty good assumption is that it can generate valid SQL. So now we are turning the focus on to understanding the user better and perfecting the use case.
Mm. Yeah, I think there have been a lot of like blog posts like text-to-SQL is now solved, but I think that's a bit, of course, like a marketing hype still. So I guess one good example of these is now also, for example, what these big companies are doing as custom projects. Like, for example, Uber has this nice like a blog, and they have developed their own like a query GPT, natural language to SQL using generative AI solution. And they kind of started pretty small in some kind of like a hackathon kind of way. And then they came up with their first versions. But I think what is interesting to see here is that, I mean, this is the kind of like a model how they were kind of instructing what kind of SQL to generate. So to answer the question, we need to join this and this table and then use this and this kind of filters and what kind of columns exactly to use and so on. And if you look at this kind of level of instruction to the model, it becomes kind of evident that, I mean, these are very custom solutions that are then in use. I mean, if you think about some like a bit smaller company, they wouldn't really have the resources to start like explaining their data and queries on this level to the models. So it seems that in order to get something to work at the moment, you have to have like quite a lot of resources and quite a lot of resources also to kind of really explain every single like detail of your database model. That sense. So how would you comment this, for example, Olli-Pekka or Mikko?
Well, the first thing to do is, I guess, or first thing to try, like Uber did, is to like use some kind of RAG system to fetch the relevant examples of queries, and based on that, generate the query based on the user question. But as the Uber actually in this text, they realized that that doesn't work as well as they thought it would work.
Yeah.
So they had to design quite a lot more complex system that first maps the user into the correct tables and workspaces, and after that they can generate the SQL query. In practice, that means that they have like this kind of filter that selects the correct tables from a huge amount of tables, and then after that they can start generating the SQL queries. And even that, for that they require to separate the agent that then can probably make the query, and after that they need a third agent that still filters the query to the final form. So it's complex problem, and of course Uber is a big company and they have lots of data and lots of tables, but the same issues will be in any case in front of you if you start implementing this kind of systems.
Yeah, I think they in this article talk a lot about the other kind of challenge in the understanding the user intent. So you mentioned this intent, they mentioned this intent agent, and kind of really be able to understand from the user what exactly they want, like your example of that, like is London a store or something else.
Yeah.
But yeah, then if looking further also, by the way, are there any questions?
Yeah, I have a question from the public. So actually, like, how do you handle this? Because like you said, it depends on how they interpret the actual term. So how many people may have another word for the same thing. So like dialects and different languages. So how does it handle that? It's also about the intent, but that's a big challenge because everyone has their own. Every person is unique and uses their own language to try to find this or use their own text to find this. So how do you approach that and try to answer that? I mean, you can't probably get it right, but yeah, how do you make it as good as possible?
When it comes to like a different like dialects and that kind of stuff, or
yeah, with different dialects. So exactly. So yeah, like London was.
Well,
yeah.
London is London.
London is London,
yeah,
but
you could, like, I guess this could be a bit like when we started. Like, we in Finland call conversion rate hit rate quite often for some weird reason that I have never understood where that comes from. But if I use term like hit rate, how does the LLM know that it's actually meaning the conversion rate? Well, I guess that's large language models are good in exactly that kind of thing, but probably maybe Olli-Pekka or Mikko, you can give more background on why they are actually pretty good in that.
Yeah, they're pretty good at that because they've seen a lot of text. That's the short version. So they've been trained on such massive variation of text that they have some sort of understanding that, okay, these are the words that look different but may have similar meanings, so they can do this kind of classification or mapping tasks quite well. But it's very interesting, like if you look at this Uber blog post, it's a very nice example, very nice write-up of this text-to-SQL. So you have these technical challenges that you need to solve, like, okay, can we generate a valid SQL query? Yes. Can we find the correct data to hit the context? Yes. If the query doesn't work, can we rerun it? Yes. These are the basics that have to be there in place. And then we get to the interesting question that, okay, how do we handle these unclear inputs where we don't necessarily maybe know the intent always? And there are some solutions that you can look at. Also, some of them were found in this blog, but we can simply try, okay, what would be the simple queries that have to work in order for the final query to work? So, for example, do we find the London or something related to hit rate in any of these columns, and then try to work from there piece by piece to get the final query results. But it's also interesting to think from the point of view that could a human answer this question? And if they could, then how would they approach it? And then try to build a similar logic with the language models. And we shouldn't exactly assume that they perform like humans do, like they can make silly mistakes that humans wouldn't, and they can get hard problems right that humans wouldn't get, but it can be a useful analogy to start getting the feel for the logic that we have to implement.
Yeah, that makes sense. And actually, in this Uber case, I guess the learning part is pretty interesting to read, that what they have learned from these projects they have been doing. And they are also highlighting that large language models are excellent classifiers. So they do know their language stuff and can group things together based on the similar meanings and so on. But the hallucinations is one of the big problems in this text-to-SQL or natural language to SQL area, and they are also working very hard in solving that still. So basically, LLMs have this tendency that they can, for example, generate a query with tables that don't exist or with columns that don't exist on those tables. So, and I have discussed about this topic with some people also, especially the SQL joins are very difficult to get right. So that is an area where, of course, you do need to put a lot of effort into the kind of metadata quality area that the LLM really would have such instructions that it can generate complex queries correctly. But what's your kind of Olli-Pekka, Mikko, general advice on how to prevent hallucinations in these models?
I guess the general advice would be that, especially in chat systems, you don't want to let the user to ask anything, or the chat or this chatbot should advise or ask questions back from the user, so it kind of guides the user to correct direction. And after that, the hallucination problem is smaller, because the queries that the user write will become better, and then we get much better SQL queries from that, and that limits the hallucinations. Chat systems in general are quite hard to get right, because each user has their own way of asking questions, and some people just write 3 words and use it. suddenly understand what they mean from that. And some people write them maybe a couple of sentences, and that's much better because they can detect the intent from that much easier.
Is there, can I intersect with a question? It's like, is there any, does it prefer like less words or more words to get the best kind of SQL answers? Is there like, it always depends on the user, as you said, but is there some like perfect middle ground or something that would be ideal to get the best kind of answers?
I think it depends on the problem and the use case. If the use case is simple, then a couple of words might be enough, but when there are complex queries in the background, you need to input more information for the language model, and that's, in the end, the user has to give the information.
Yeah, another aspect to look at it, maybe not more or less input, but how can we actually restrict the input space that we ask from the user? So that's the biggest user experience and engineering factor that comes these chat systems. Can we somehow guide the user so that the data that we get to the LLM is actually somehow restricted or validated? Because then we have to do less work on the intent detection and logic because we can trust the input more.
True. Can you use some LLMs to maybe guide them like predetermined answers or stuff like this and have them like, yeah, it's an UX question, yeah, how to get it as good as possible. I'm not an expert in this, but yeah, just
I guess it's sufficient to say it's a very complex problem, and you can try to solve it in multiple different levels, whether already right away the UX or later on with the LLM or still later on in the backend systems. But yeah, it depends on the use case, I guess, as Olli-Pekka said. But I guess it tells something about the challenge of this, solving this problem, that if you look at demos from these big players like Microsoft Power BI Copilots or Snowflake's Copilots, I mean, they are trying to build those generic solutions, and it's really hard to solve this problem. And the demos normally have a one table and two metrics and two dimensions. And with those, they can show that it works. But when it gets even slightly more complex, then the whole thing easily breaks down. And in real enterprise data warehouses, you have hundreds or thousands or tens of thousand tables and very complicated queries and so on. So it's not like you can actually do anything too useful if your solution works with one table that is massaged to be perfect for one couple of certain kind of questions that you can get out of. But this Uber example is really fascinating, and I think the conclusions here are really interesting, that how they are have been doing this and how they plan to go forward. And they have also measured that they have quite happy users now with those certain use cases that they are able to solve with this solution. So I guess we could say that Text-to-SQL is not really fully solved, even close to it, but there are definitely use cases where you can solve it when you have capable technical teams and they understand the business domain. One thing actually here that's also interesting is that what kind of size of data they are dealing with. So, for example, at Uber, the data platform handles approximately 1.2 million interactive queries each month. So they are also working with quite a lot of data. But of course, for example, at Zoined, when we are a fully a data focused company, in the sense that our SaaS solution, which is a analytics solution for retail and restaurant chains, we deal with queries all the time. How much, Karipekka, do we currently have, for example, queries running every day?
Well, it depends a bit on the day, but I would say that it's a rough estimate from 500,000 to 1 million queries per day.
Jesus.
Well, your backend side. So that is definitely. And one aspect related to this is talking about this understanding the intent, the user, what data results the user aims to get. But one aspect with SQL is that there is often a possibility to get the same results with a different kind of queries. And some of the approaches are way more optimal than others. So the query might work, but it may then put a big strain on the database side and cause other queries to slow down or even take forever to get results. That is one aspect. Well, not only getting the query as optimal way as possible.
What about then also being able, of course, to handle a lot of parallel queries, but that's actually kind of an interesting topic I have been thinking about a lot, that how could we utilize these AI-powered assistants to actually run a lot of parallel queries, because at least in theory, you could then process huge amount of data in a very short time, but that then, of course, requires quite a robust backend data warehouse and query infrastructure. But how is it, for example, in our case? I mean, normally on a busy day, how many parallel queries are there, and ETL loads and all that?
Well, accordingly, we have been doing this measure that it's based on how many API requests come in at any given time, so it keeps track. So there might be several hundreds of these kind of requests coming in at any given time, especially during the busy times, like Monday morning, for example. And then those generate usually at least one query, oftentimes more than that if there are comparison series or some metrics that require more several queries to be run. So it's definitely, and for that it's very important that all of the queries are run as optimally as possible, because even single very slow query there can cause entire system to slow down significantly.
Yeah, that's a good point about the kind of multiple ways how you can generate a query, and if you want to kind of provide those fast response times, you cannot allow a very heavy queries running on the database. So, but yeah, that's an interesting topic for sure. But I guess in the end, it would still be nice to hear also from Olli-Pekka and Mikko your kind of ideas that where do you see this whole area going in the future, and how long does it take for the world to actually solve this well enough?
Solve, yeah.
Text-to-SQL problem.
Well, I left my crystal ball at home, so I will not give a yes on when it will be solved, but I think it's important to note that you can get the productivity gains even if it is not perfectly solved. So in the cases that you mentioned, if you're handling 1 million queries a day, if you can help 10% of those to get done faster, then you're already producing a lot of value. And then it's just a matter of the fact that can we inform the user if the query is not, if we are not certain that the query is doing what they meant, and how can we overall establish the trust that, hey, we can really boost your productivity with this system. So it comes down to a bit more machine learning engineering side, having some known data and expected results, and being able to give some number on how often your system works and in what kind of scenarios it's good and where it needs more help from the user. So yeah, it's definitely already a valuable feature to have.
Okay.
Yeah. I think the models will get better year after year, and the problems will get smaller. So it's better to start implementing right now, and then you can change the model later on to better one. For example, the Text-to-SQL generation is special problem because it's programming in practice. SQL is programming language, and the programming language special models will get better. And so in that sense, in the future, I think this problem will be smaller and easier to solve.
Interesting.
Well, Oliver, did we have any more interesting questions?
Yeah.
Let's take one still and then wrap it up.
All right. Well, let's maybe say, let's go with this one. Okay. So what's the biggest challenge at the moment? Like what's the common problem facing the industry? Or if you can point to one thing that's like holding you back from getting to the optimal state, what is it? What would you say?
Well, we can maybe take a poll. If we take from these things we have today discussed, my point of view would be maybe the hallucinations are the biggest problem.
Okay, we got one hallucinations. What does Karipekka think?
Yeah, and from the software developer's perspective, I would say that understanding the users in then what the business user really wants, that is difficult even for an experienced human developer. Many times, though, it's certainly difficult for a machine to understand it.
Probably won't solve it. Olli-Pekka, Mikko, do you think biggest problem right now?
Yeah, that's a hard question because there is quite many problems in this space currently, but I think it's related to the users and users not understanding yet what is possible with AI and the company is not understanding what is possible, and that's like the biggest problem from my point of view. So it requires quite a lot of explaining before we get to do something. So that's
yeah. Maybe building on that, like picking the low-hanging fruits where you can do something that adds value is sometimes like surprisingly difficult to get in the correct way, because you have to have some knowledge of what the systems are currently capable of to actually identify the best or the right problems to solve here. So that takes work, but it's worth it in the end.
Yeah. This maybe says that it's like you shouldn't aim for perfection, but maybe something in between that you can get the productivity up at least some 10, 15%, whatever, not the 100% more. But can't solve all your issues, but it can help along the way.
Yeah, as long as we generate enough value for business, then it makes sense to implement. And I think every month going forward, we will be able to provide more value because also the LLMs keep improving. And of course, people learn now more about how to build these kind of solutions. So we are in better position to tackle with all these challenges we discussed today. So we kind of focused on all the challenges now in this webinar, but I think the bright side is that all the solutions are also getting better all the time. And now you can already do pretty amazing stuff like we have now seen here. But I think now it would be a good time to wrap up and thank all our guests from Softlandia, Mikko and Olli-Pekka, and also, of course, Karipekka and Oliver for the good discussion. And yeah, we will surely have some webinars coming up that are more technical in nature also in the future. So thanks, everyone.